This video is going to talk about negative exponents, which might be something that looks like 2 to the negative 3 power, x to the negative 1, y to the negative 2. Any base raised to a negative exponent is what we're going to be looking at today. We're going to start by figuring out what this notation is trying to tell us. Let's go back to what we know about positive exponents and see if we can form something from there. So let's start in this table. 5 to the third power is 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. So 5 to the third power is 125. 5 squared is 5 times 5. Most people know that that's 25. 5 to the first power is 5 times 1, okay? 5 times, or just 5. We don't need to think about that one as being multiplied. So this one's 5. And 5 to the 0. Well, let's check out the pattern that's happening here. What's happening to the exponent each time we go to a new column? Well, the exponent is going down by 1. So I'm subtracting 1 each time. And there's a corresponding mathematical operation that's happening in the second row, and that is that each time that the exponent goes down by 1, the number down here is being divided by 5 to get the next entry. So 125 divided by 5 would get you 25. 25 divided by 5 would get you 5. And so now when we're subtracting 1 in the exponent from 5 to the first to 5 to the 0 power, again, to get this next entry, we just need to divide by 5. Well, 5 divided by 5 is 1. You've probably been taught before that anything to the 0 power is just 1, and here's why. Okay, it follows the pattern, and now we're not multiplying any 5s together, so there's just a 1. We're going to continue this pattern by going from 5 to the 0 power down to 5 to the negative 1. Well, if we've continued the pattern in the first row, we need to continue the pattern down here in the second row by dividing by 5. So 5 to the negative 1 is going to be 1 divided by 5, or 1/5. We'll do the same thing for the next column. 5 to the negative 1 power, subtracting 1 from the exponent gets us 5 to the negative 2 power. So in this second row, we're going to do the same thing of dividing by 5. Well, 1/5 divided by 5 is like dividing 1/5 by 5 over 1. Dividing by a fraction is the same thing as multiplying by its reciprocal. 1/5 times 1/5, multiply across the numerators, you get 1. Multiply across the denominators, you get 25. So 5 to the negative 2 is 1/25. And last but not least, we go down another exponent to 5 to the negative 3. We're going to divide by 5 again, and in this case, we're going to divide by 5 again, and in this case we have 1/25 divided by 5, so same thing as divided by 5 over 1, 1/25 times the reciprocal 1/5 is going to get us 1 over, well, 25 times 5, we know from earlier, is 125. So this is 1/125th. In addition to the pattern we already saw, I'd like to point out that from 125 to 25 to 5, 1, 1/5, 1/25th, 1/125th, not only are you dividing by 5 each time, but there's actually a little bit of symmetry here. So in the center, we have 5 to the 0 power. And over here from the left, we had 5 to the third power, 5 to the second power, and 5 to the first power. Now here, where we had 5 to the negative 1 power, it was actually the same as 1 over 5 to the first power, the positive first power. 1 over 25, 1/25th, came from 5 to the negative 2, and that we could consider as 1 over 5 squared. So what do you think I'm going to say here about 5 to the negative 3? We can think about that as 1 over 5 to the positive 3. So any time that you're dealing with a negative exponent, say perhaps you have 2 to the negative 3, you can think about that as 1 over 2 to the positive 3. you can think of x to the negative 1 as 1 over x to the positive 1. A negative exponent tells us we're dealing with something fractional, okay? 1 over the base to the positive version of that exponent. Let's look at that a different way if you didn't understand the explanation with the pattern we just went through. From your exponent rules, you may remember that we might take something like b to the 5th times b squared and get b to the 7th as our answer, because this is 5 b's multiplied together for b to the 5th times another 2 b's multiplied together for b squared. Okay, so there's my 5 for b to the 5th, there's my 2 for b squared, and there are how many b's being multiplied together? Well, 7 of them. Okay, so we got b to the 7th by doing b to the 5 plus 2. Another thing you may remember is that b to the 5th divided by b squared comes out to be b cubed, because you have 5 b's multiplied together in the numerator, 2 multiplied together in the denominator. Well, 1 from the numerator and 1 from the denominator are going to cancel out because b divided by b is just 1. So you'll be left with b to the 3rd power. Now, what happens if the numerator's exponent is smaller than the denominator's exponent? Well, in this case, that's b times b over b times b times b times b times b. These two will cancel out. These two will cancel out. So b divided by b is 1, b divided by b is 1. So there's actually a 1 left in the numerator once those b's are crossed out. And we have 1 over b cubed. Well, in this previous one, we did b to the 5th over b squared, and we got 3 as our exponent, which we could have gotten by doing 5 minus 2. In this case, with b squared over b to the 5th, we can think about this as b to the 2 minus 5. Well, 2 minus 5 is negative 3. b to the negative 3 is the same as 1 over b cubed. Remember what we were seeing in the previous description was that anything to a negative power can be written as 1 over that base to the positive power. So here we have another explanation for what a negative exponent is and how we can interpret it.